Okay, so in this third topic we're going to be covering in this course is software overview. So a couple things we're going to talk about within software. Number one, we're going to define it. We're going to talk about the two primary categories of software. Talk about something called ERP software. And then we're going to focus on cloud computing. So there's a big area that's under development in the industry around cloud computing. We're going to talk about that, and then we're going to wrap up with a couple points regarding open source versus closed source systems and kind of what is an open source system. Okay, so at the beginning here we have a couple videos. These are on YouTube, basically providing a description of a couple different perspectives of what is software, and also this idea of software and services. So you can take a look at those on your time. So starting off from a definitional perspective, software basically are the instructions that tell hardware what to do. The question of what's more important, hardware or software, really one's not more important than the other. It's a matter of hardware and software working together. One without the other basically does not do anything. So basically the directions that to tell a computer what to do. Right. There's two primary categories of software that we talk about. One is something we call an operating system. So that is that's what you install onto hardware, which actually gives you the ability to manipulate and use the hardware. So, some examples, well-known examples: Microsoft Windows is an operating system, OS X is an operating system, iOS on your tablet or iPhone. Linux is an operating system, very big. We'll talk a little bit about that downstream, but those are all operating systems, and the primary functions are they manage the hardware resources, they provide some form of user interface, and that can take any form. So obviously, if you look at your traditional command line, that was the user interface that was in that was in the system, that was in the computer. It's been supplanted by GUIs and things like that with Windows and Macintosh and whatnot. But there's always some type of user interface. And third, it provides a platform to run software applications. So what are software applications? So the purpose of a application is from a high level, it allows users to accomplish some goal or purpose. So it can take many forms, it can do many different things. It's basically what you want it to do. So, some examples we're showing here, Office productivity, Microsoft Office, basically everybody uses it. Web browsers, so you have multiple different types of web browsers. So you've got Internet Explorer, you've got Chrome, you've got Firefox. So, and then the browser itself, and then the accessing the application that's running on the web server. Media players, so things like iTunes and streaming are all basically implemented through software. Video games, basically the whole gaming market is just a very sophisticated version of software. And then finally, this idea of utility and programming software, because you have to have something. You need software to be able to write software. All right, so basically there's some different types of utilities, like Microsoft has what they call Visual Studio, and basically it's a program that lets you write programs. All right. So what does software look like? So we'll take an example here. So this is an example of a program written in C. Right? You see, it's a fairly simple program. All right, so we define A, we define B, and then we create another variable C, which is equal to the result of A plus B, which should be 30 at the end of this. All right, so it's pretty, even if you're not an expert in C or programming languages, seems to be pretty straightforward. So let's take a look at how the computer actually sees this. All right. So this is the same program. All right, but after it's been run through a compiler. And what a compiler is a translator. It translates data, what do we call source code, which is basically what is the programmer's code. It translates that code into what he calls assembler language. All right, so this is a different command. So that you kind of read this as a push, which is a push command. The MOV is a move command. Add is add command. So what we see here, we have three steps in the program. All right, but that translates to 1, 2, 3, 4, 5, 6, 7, 8, 9 instructions for the computer. All right, so you usually will see more instructions per, than if you have source code versus instructions, and you kind of count them both out. After you translate it, you'll have many more instructions. All right, so this basically what we'll do is it'll move this to registers, add the results, and then move that to another register, and then pop it and basically pop the state. But basically, this is the result of the translate, and this is what the computer can deal with. All right. So actually, if you look over here on this side right here, this is what it looks like in hex. All right, and then which is hexadecimal, which is base 16, which is then ultimately broken down into 8-bit characters in bytes. All right, so this will give you kind of an idea of what an actual program looks like that's actually executing. So this is a teeny tiny trivial program. Imagine when you have something like Microsoft Office running, the amount of code that takes, and or things like Amazon.com, how much code that could actually be, how many instructions that would actually look like. So there's a couple different classifications. We kind of group this stuff together. So there's one classification of software we call enterprise applications, which is really, the best way to describe it is software that basically are used by organizations to achieve, for a particular purpose. All right, and there's three kind of major categories of these things. So the first one is something we call enterprise resource planning, ERP. And what it is basically a system that can do everything that a business needs for it to do. All right, so it does all their accounting. It can do human resources. It can plan scheduling. It could do schedule plant maintenance. It can do accounts payables, accounts receivables, everything. All those functions can be executed within this ERP system. All right, so and most organizations will have something, if not a formal ERP, something that usually will look like a ERP system. The next major category is something we call CRM, customer relationship management. So it shares a lot of characteristics with the ERP system, but has a specific focus on customers. So basically, a manage organization's customers, developing personalized relationships with each customer. Basically, it wants to know what you're buying from them, when do you buy, what will you buy tomorrow. So there's functions within this software that do things like that. Third major area is something called supply chain management. So supply chain is basically the path, the data, or basically the process through which companies move goods, services, raw materials through from one side to another. So basically you have inbound supply chain, which is like your raw materials and supplies. You have outbound supply chain, which is basically goods to market. All right. And so this is an application that really provides all of the capabilities that you need to run this stuff. All right. So you're managing as we say here, managing the links between suppliers, manufacturing facilities, and distributors of products. So basically, it kind of does everything. But the difference between like a supply chain and an ERP would be ERP is focused internally, whereas supply chain is actually is connected with suppliers. And then customer relationship is also basically focused on customers. All right, so you see a little bit of a difference between these things. All right. And then there's other types of applications, enterprise applications. So could we call out a couple here, like electronic mail, workflow, portals, giving access, being able to have a common place to be able to log in at. So those are all basically what we call enterprise applications. A relatively new area for development has been this idea of mobile applications. All right, so um, you know mobile applications have kind of evolved over time. I think the big jump on that was with the introduction of the iPhone. Okay, so as we were talking about, let me go back into our slide here. Talking about mobile applications. So with mobile applications, as we had talked about, basically mobile devices, phones and tablets are relatively new. I mean, you kind of date the stuff back to the release of the iPhone back in 2007. But the applications, we call things we call apps, are relatively, they came out as part of the release of Microsoft, excuse me, of the iPhone and other um, devices like that. All right, so and they are applications, so specific mobile applications is specifically programmed to run on a mobile device. The question of the mobility, the portability. Basically, an application has to run on, it has to be programmed to work on specific hardware. So we'll take, for example, if you write something for an iPhone, you're not going to be able to transfer it over to another platform. You can't run it on a PC because it's a different type of machine. Um, and it doesn't run on an Android or an Android either. So you have to, from a programming language perspective, when you get down to, as we convert it and actually execute instructions, that is very machine specific. All right. And then finally, there's kind of the point around mobile device being friendly website alternative. There was if you look at kind of the adoption of the internet over the past 20, 25 years, you had a big swing as it started gaining commercial appeal. Um, a lot of what's happened, though, is as people have become more familiar and more accustomed to using mobile devices, there's, it basically we're using mobile devices as an alternative or a complement to websites. Right? So it's like different ways that people can get to um, online resources. All right. So, but from a programming perspective, they are totally different. All right, a couple things on cloud computing. The couple videos here. Salesforce, what is cloud computing, is a pretty good high-level overview of some of the advantages of cloud computing from the perspective of Salesforce.com. And then there's some details here around, um, these are actually documents. So NIST stands for National Institute of Standards and Technology. And they actually have done a lot of work around establishing definitions of what do we mean when we talk about cloud computing. So what do we mean when we talk about cloud computing? Um, Basically, cloud computing is there's a couple different dimensions to it. So one is that if you can imagine this idea of running hardware on as software. All right, so the idea of you can take a PC and convert it to be able to be run within another machine as an application. All right, so um, this idea of virtualization has been around about 10 years now. All right, and it is a major part of how systems are running these days. So categorize cloud computing as being a combination of leveraging virtual systems and access to the internet. So the other big part of cloud computing, it uses the internet. So what happens is you go out You can go out to a cloud provider and you can basically stand up a server or machine, um, and it's a real honest to goodness computer, that you can access. So it basically uses very large server farms and massive storage devices. I mean, we're talking enormous. So the idea is that you can get this stuff on demand. You just go out. If I needed a server, I could just go out, and in 5 minutes I would have a server up and operating, be able to run stuff on it. All right, so it uses very, very large server farms. And there's some big providers. Probably the biggest provider right now, the biggest two providers. One is Amazon, uh, something called Amazon Web Services, AWS. So if you go to aws.amazon.com, what you'll take you to a whole different kind of website than your traditional Amazon.com. All right, so and they have a very sophisticated, the ability to kind of stand things up, and basically, and the way it's set up is that you pay for what you use. So you can create a machine, you can run it for 3 hours and only pay for that 3 hours of usage, as opposed to, if you bought a regular server and stood it up, and you could run it for 3 hours and then you still have the server there, which may not do anything. So a lot more flexibility. The idea of this on-demand network access, computable. So some of the terminologies we see here: shared pool of configurable computing resources, rapid provisions and release with minimal management or service provider interaction. This is all straight from NIST standards, or this is a NIST definition of it. All right. So the two right now is at AWS, Amazon, and then the other one that's big is Microsoft. Has been very big into the space, and their cloud platform is something called Azure. Essential characteristics. We've talked about some of these. On-demand self-service. You don't need somebody to set it up for you. You go out, you select it, it automatically creates a machine for you without intervention. Broad network access, so you can get through different, it's accessible on the internet. So this is, as I said, part of the cloud definition, or the essential characteristics is it is an internet-based device. This idea of resource pooling, so the idea that it looks to you like you own the machine because it looks like your computer. The reality is it's running along with all these other thousands and thousands and thousands of other machines. So this idea you can pool resources to serve multiple customers, and you're kind of dynamically creating and shutting down resources as you need them. Right? Rapid elasticity, which basically speaks to, it's kind of a similar fashion. Basically, capabilities are provisioned and released to scale based on demand. All right, so basically, when you need it, you can get it. And actually, to some degree, there's actually some capability to automate that stuff. So what'll happen is that as you get, you don't necessarily have to be sitting there by your terminal waiting for the thing to go. You can actually set some rules in some of these platforms, which you'll say, once they get to a certain point, add more servers, or if a utilization level drops, take some away. All right, and then finally, this idea of a measured service. So everything is metered. So they basically charge by unit over time. All right, and you can buy a server, or you can get server functionality, or you can get storage. So basically they have their own charging mechanisms. One of the biggest challenges sometimes is when you go out and you create a server and you spin it up, and you forget to turn it off and you log off. The machine is still running, and which you will discover when you get your Visa bill at the end of the month and realize you've got a $700 charge, which has to be then negotiated out. Right? So this is just kind of it's a little bit of a busy picture here. The main thing is really in this kind of this layer right here. So you've got what they call physical. So this is basically your physical hardware, where the real system, because it runs on real computers, ultimately has real storage, real computers involved with it. This top layer here is, I'm going to kind of talk this. This is basically where the virtual machines are at. or virtual machines running. And then there's this layer right here. This middle layer is the thing that actually handles the communication and kind of the translation and, you know, basically allocating between the stuff between the physical stuff and the virtual stuff. Okay, so NIST is actually, you know, one of the big challenges that people run into with cloud computing is nobody understands it. All right, so what NIST has done is they've actually have gone out and they have defined some different what they call service models, which are basically, you know, the way a cloud computing is used. So there's three main service models. So the first one is what we call software as a service. So basically, from your perspective, you're logging onto a website, you run an application. So you don't see anything behind the scenes. You don't see the systems, you don't see the storage, you don't see anything. All right. The bottom one, infrastructure as a service. This is kind of what we were talking about with Amazon. So Amazon Web Services is categorized as infrastructure as a service. So basically, you can stand up and run computers, storage, networks, network infrastructure, all within this virtualized space. That's IaaS. And platform as a service is, if you can imagine, it's infrastructure as a service, but what they'll do is actually add some additional capabilities like databases and development tools. So the idea is that from the vendor's perspective, you know, you have an IaaS, somebody logs in with IaaS, but if you start using any of the tools, you know, from the platform perspective, basically, you know, you've locked that person, that organization in on that cloud, because, you know, there's the tools that each vendor creates, so the tools that Amazon has versus the tools that Microsoft have are not transportable. So basically, if you think of PaaS as kind of like a glue trap. So. Yeah, and this is just kind of a high, once again, kind of a high level of, you know, applications versus middleware versus operating system, kind of the IaaS versus PaaS versus software as a service. Another picture, also from NIST, around kind of the functionality that you would see from a different cloud, you know, basically cloud system. So like the IaaS is more stuff, more hardware-related stuff. Consumer software as a service, basically you're buying access to functions, but you're not buying access to the hardware or any of that stuff. And then the PaaS is something in between. All right. Now, in addition to the four or the three service models, there's actually, NIST also has another what they call deployment models, which also describes how a cloud is deployed. So what you've got is four. So the first one is what they're calling a private cloud, which is, think of it as, you know, an organization has their own internal systems like they've always had, but they use a lot of the cloud functionality, like, for example, virtualization, automated provisioning functionality. That's all part and parcel of what we would call a private cloud, only used by that company or on infrastructure that they own. Community cloud, I'll come back to that in a sec. So public cloud is kind of the opposite of public cloud. So the idea is it is for open use, it is shared resources in general public. You know, the Azure and Amazon Web Services are considered public clouds. All right, and then hybrid cloud is really kind of a combination of public and private. All right, so a public cloud, a hybrid cloud would be, you run some things in-house, and then you also use an external cloud, and they kind of interoperate together. All right, and the community cloud is just there's a specific category of users, or we call it here community of users, consumers from organizations with shared concerns. So it's more around kind of common use and similarity with the customers. So these are the four. So, so when we look at cloud computing, you think of the three service models and the four deployment models. Okay. And this is just kind of a pictorial view of our cloud deployments. you know, some of the advantages, and these, depending upon what you use and how you use it. All right, so no, one thing you don't have to do, you don't have to install software, you don't have to install operating systems, you don't have to do upgrades. That's all there, available for anybody who has access to the internet. You can support very large numbers of users. To give you an example, Netflix actually runs all of their movie sharing systems on AWS. So that's all coming out of a cloud. Applications can be up and running very quickly. That's kind of that, the dynamic nature of the cloud. Services can be leased for a limited time or on an as-needed basis, or it can also be long-term. So you'll see a lot of times, like for example, what Netflix does is they'll actually adjust the number of servers they have set up for time. So 3 o'clock Sunday morning, you'll probably have less people watching movies than maybe 7 o'clock on Friday night. And what you do is you basically spin up enough drives or enough systems, enough resources to be able to handle that. Information is not lost if the hard drive crashes or the device is stolen. Yeah, so basically, there's a lot of backups. You can run your own backups. There's backups inside these clouds. This is one of the functions that they provide. And then finally, it's not limited to what you're running on your individual machine. So you can actually, so if you're running, like I'm running on a laptop right now, and if I wanted to run a 5-core, or basically I could say quad processor to do some sort of mathematical calculation, I could go out to AWS, stand up a processor, run all the stuff on it on my Macintosh. All right. Some disadvantages, there's always a question around security. So the question of, are you, is this stuff secure? Are people able to see your data? And, there's actually one of the big things that cloud providers have been focused on is really providing security tools. Now, having said that, is it possible for somebody to go into a cloud and deploy it in an insecure fashion? Very, very much so. It's only going to be as good as you can build the tools, but then, but somebody has to use the tools and have an understanding of stuff. So a lot of times what they've said is cloud platforms can be even more secure than running stuff in-house, assuming they use the proper tools that are in place. You have to have internet access. All right, so that's a given because it is a cloud, it is an internet-based platform. And then the question of, you're relying on a third party providing you services. So, like for example, if you're running on Amazon and Amazon has a problem, Amazon goes down, well then you're kind of out of luck as opposed to if you had it in-house. So there's a couple questions in looking at this in terms of how much availability, what type of systems you have, so on and so forth. All right, this is some of the major players. We've talked about AWS, we talked about Microsoft Azure, Salesforce.com, which is a software as a service. These are two different things. Google App Engine is a platform as a service. Azure is infrastructure and platform. AWS is infrastructure platform. So this is some examples of some of these different cloud providers. Some names you know, some names you don't know. All right. So finally, we want to talk about open source, this idea of what is open source software. I don't know if you've heard of this. We'll talk about kind of how systems were developed or how software was written before. For the longest while, software was written and licensed. You had to acquire a license. So a company like Microsoft would develop Microsoft Office, write Excel as a program, and to be able to run that program legally, you had to have acquired a license, i.e., give Microsoft a bunch of money. All right. So the idea is that, and then software companies have been running this for a long time. However, this idea of an open source, so there's another perspective on this, and from the open source side, a software is a shared good. And that basically all source code should be made available, and people can be free to both um, modify it, extend it, within specific rules has been developed. So you've got this like open source communities, and this is on operating systems. So Linux is an open source operating system. So what you do with Linux is, you can download Linux and you can install it on your PC, and you don't have to pay anyone. Right? If you have Microsoft, if you download Windows and install it, there's an expectation on the Microsoft side that you're going to need a key to make it work. All right. Some other examples we're seeing, in databases, or probably as another example, we're seeing, a big push on open source. Closed source systems, companies like Oracle. All right. Oracle makes a large relational database system, which we'll talk about in the next section. But Oracle, and talking very large, they've done quite well for themselves. Over the past 5-10 years, there's been a big push to basically develop open source databases. So you've got things called like PostgreSQL or MySQL, and a lot of websites now, these large, like the guys doing Amazon, probably to a large degree, but also like Facebook. All of Facebook is written open source software, so they're not writing a check to Microsoft. They basically took open source software and adapted and used it themselves. So the difference is really around a licensing issue. You can argue it both ways, but for the most part, you've seen open source here. It's still making inroads into the industry. All right, so does that make closed source go away? Not in the least. All right, so this is always going to be kind of both are going to be out there. Both are going to have there's certain areas where open source will make more sense than closed source, and vice versa. Right? And that is about it. All right, so here's the study questions, and we kind of take a look at these. In addition, our reflection homework questions. So pick one of these and basically put your thoughts down around a kind of what you think about some expectations you should do. For this one right here, the one I would suggest, I've told people, the thing you want to look up is Hershey, the candy company. Hershey ERP implementation, and see what you come back with. Okay? And that is about it. Thank you.